In the last video, we talked about if you have two congruent triangles, then corresponding sides are congruent and corresponding angles are congruent. And we also talked about how the converse is true. So if you have corresponding sides that are congruent and corresponding angles that are congruent, then you must have two triangles that are congruent. We're going to look at a proof now involving that theorem. We're given the triangle ABD is congruent to triangle ACD. We can start with the given. And let's look at what we're trying to prove. We're trying to prove that segment AD bisects angle BAC. Think about what it means to bisect. If AD is bisecting that angle, then both of these angle measures would have to be equal. So if we can prove that the measure angles are equal there, then AD must be bisecting the angle. Well, we actually can prove that those two angle measures are equal because these are two congruent triangles, and angle A in the first triangle is congruent to angle A in the second triangle. So angle A in this triangle is congruent to angle A in that triangle. And that's because those are corresponding parts of congruent triangles. So the measure of angle BAD is equal to the measure of angle DAC. And that's because corresponding parts of congruent triangles are congruent. Some people abbreviate it as CPCTC. And finally, because we proved that, AD must bisect angle BAC. And that is by definition of what it means to be a bisector.